Well, after that video on the clock and the mini rack, I decided I would try incorporating some of the feedback I got in the comments. One thing is everybody's noting that this is a hour, minute clock. So why do you need so much precision from GPS to get down to microseconds or even nanoseconds at some point? Well, it's mostly because it's fun. But also, if I can get a PPS output on here, I could use this GPS module to drive other clocks. To get that, I need a PPS signal, and looking at the wiki, it said something about GPIO 16 being connected to something. I don't see a way that it is on the board connected to, I think, one of these pins over here. But it did say that the PPS signal that's routed to this LED that's blinking up here, you can see it blinks once every second, it's routed to the second resistor on this row up in the top here. And if we look at it on an oscilloscope, we can see, if I can make contact with it, that there is a pulse there, and it's about 2 volts, and it goes off exactly at 1 hertz, which is a pulse per second. So I could solder a bodge wire from that part of the resistor over to one of these pins, like GPIO 16, and then I could use that PPS internally on the Pico to drive its clock circuit, but I could also route that PPS signal out to a plug on the exterior of this guy, so that I could use it for other equipment and get a true stable 1 PPS output. It's only 2 volts, which was surprising. I thought it would be like 3 or 5 volts or something, but I guess that's how this one is set up. But that still can be useful because you take the rising edge. So if you look at the rising edge, you can say right at that moment, it's exactly 1 second between each of those pulses based on the GPS satellite clocks. So that's going to give a very precise timing signal that you can use for radio astronomy. You could use it for ham radio frequency tuning. You can use it for clock experiments, all kinds of fun things. And it's probably going to be the most accurate timing signal that you get, short of having your own rubidium clock. And it's probably even more accurate than that if you have a good lock on the satellites. Or if you have a cesium clock or something, which we aren't going to have today. Looking more closely on the wiki, there is an instruction to put a 0 ohm resistor right in here, and I did the solder bodge job of the century there. First I was just trying to bridge it with a solder ball, but that wasn't working, so I took a little piece of wire and stuck it on there, and that works. It's not recommended. I actually ordered a component book, so I should be able to do those more cleanly in the future. But now the PPS is routed, so there was routing on the PCB over to this pin, which is GPIO 16, I think pin 21. And if I look at that on the scope, now I can get PPS output straight off that pin. So I think what I'm going to do is that can be read on the Pico itself, but I can also extend that with that and a ground lead over to another SMA connector over here for PPS out. So I'll have GPS antenna input and PPS output so that I can use this as a timing device with a clean 1 hertz, 1 pulse per second signal. So now I have the clock display plugged in, and the problem here is that without any filter or cover on it, all of the digits are kind of hard to read. This isn't just on the camera. In the real world, this is hard to read as well. I have this set to 15 brightness, which is the highest brightness level for this display. And even if I dim it, then there's PWM, and that makes it look really bad on camera, and it makes it even harder to distinguish the digits on this display. So the traditional answer to that is to put a filter over this. And if you look at any clock that has a display like this, you'll see that it probably has an integrated filter of some sort. Over here I have a clock that Master Clock makes, and they have a large, I think it's just acrylic that's tinted. That kind of mutes the thing a little bit and makes it so that the bright light comes through, but the other colors behind it don't as much. But even there you can still see the LEDs. One thing that a lot of people will do with LEDs is they'll buy UV car tint. This comes in a big roll. This was $5 for a roll with probably enough filters for thousands of these clocks. But I just cut off a little piece of it, and if we put it over here, you can see that that does do a pretty good job. One issue now is that the filter itself needs to be really flat, and even then it will be very reflective. So it helps you see the digits really well, but it's also a little bit hard to get it affixed. So that was my first attempt, and this could work. You know, I don't have a problem with this really. It's just that it's a bit glary, and I would need to find another version of this UV tint that's not so shiny. Another option is, this is red, This is a kind of a bluish tint, so this is going to look funny when I'm done with it. But this is tape that I got from a website that I will link to in the description. I don't remember what it is, but the cool thing about this tape is it is exactly the right height for this. This is with the backing on, so you can already see it makes a difference, but I'm going to take that backing off. I should be able to get this on there. It's really hard to do this while I'm filming to make sure that you can see what I'm doing too. But we don't have to be perfect, but there we go. And that does make a pretty good difference. Now it's kind of like a reddish yellowish tint because of the blue underneath. But that does help. And this is another solution. You can buy this tape from that company. I think they even do like custom tape rolls and custom sizes if you want. You might have to pay a bit extra for that. But the nice thing about this is this fits that perfectly. And if you have red LEDs, this would actually work a little bit better. But you can still see some of that background there. If you stack 2 of these pieces of tape, that might do a little bit better, but that also dims it a little bit. All these solutions will dim the LEDs, and you know, that could be desirable, especially if you're building a clock for like nighttime use or whatever. But another solution that a lot of people suggested was, well, there's 2 things. One is all these test prints that I was doing, I was printing the whole thing using a lot of plastic. People said when you're slicing it up to print it, why don't you just cut off all the parts that you don't need so you can just print off this piece? Which, yeah, that's a good idea. I never thought of doing that for some reason, but now I will do that a lot more. But what I did was I printed this with a 0.012 millimeter layer height. So on the front side, this looks like it's just a solid block of plastic. But when I put this little clock inside here, you'll be able to see that it actually comes through. Now that's very dim, and the reason for that is this filament is a black inland PLA, but they make a lot of filaments that are more transparent, and I might try one of those. I think Hatchbox, somebody, Jared CO1 sent me a message saying Hatchbox makes a translucent PLA that's black, that I could do 1 layer of that, so that would be this layer, and that would let the light shine through a little bit more, and then the rest of it would be the normal black PLA. So I might try something like that. I printed a few different versions of this. This one has a 0.2 millimeter layer height, but honestly it looks about the same. The problem here is that it's very dim. If you were in nighttime mode or something, this would work fine, but for daytime you can see how dim that is. Definitely not ideal there. So I think for now what I'm going to do is I'm going to stick with this guy and use some of this tape, and then eventually I'm going to see if I can get some tape that's more of this color, because that would work better for this particular LED. But anyway, thank you for your suggestions. This is the process of 3D printing and making things is you make something, it's terrible, and you make a second version, third version, until you are satisfied with the stage that you're at. It's similar to programming. You're never going to be perfect, but you can have varying degrees of what you accept as perfection for yourself. Anyway, another Level 2 Jeff video. I hope you learned something about lens filters, and if you have any other suggestions for these, let me know in the comments. One thing I did try was looking on DigiKey for LED lens filters, and they make some that are like sized perfectly for these displays, but they're all out of stock, so I don't know what that's about. But if there's a company that makes like perfect little slot-in screens for these things pre-cut, I'd love to pick up some of those so that I can use these in future projects.